Some of the most common skills we use on Earth prove to be much more tedious in microgravity, but they are skills that astronauts must be able to master as we journey farther into space. An experiment called Fine Motor Skills is the first to measure long-term microgravity exposure, different phases of adaptation, and sensory motor recovery after returning to Earth. My colleague Lori Meggs at the Marshall Space Flight Center in Huntsville, Alabama, spoke with Christina Holden, the principal investigator of this study, to learn more.
We're interested in finding out if there are any effects of long-duration microgravity on fine motor skills. We're particularly interested in looking at advanced technologies like touchscreens and gesture devices because we think those are the kind of devices that crew members will be using on future missions. And we want to make sure that if they're on a long-duration journey to Mars, for example, that they're able to interact accurately with those devices once they go to the planet's surface.
What types of fine motor skills are we talking about?
So we are doing this study on an Apple iPad and using the touch screen. And so we have 4 different tasks that are part of the investigation. They include things like pointing to a target, dragging to a target, shape tracing, a circle and square shape tracing, and then a pinch rotate task, which is a multi-touch task for the touch screen.
Why do we need to know this?
Well, so crew members more and more are using iPads on board ISS, and so they're using a lot of touchscreen interfaces, and a lot of times if interfaces aren't designed well, there are a lot of errors. And so we want to make sure we know if there's any performance decrements after being in microgravity for a long time that we might need to accommodate with a different type of design.
Would this lead to new designs for our iPads on Earth?
Yes, we're very excited about that. Actually, the particular application we think it has is for populations who do have problems with fine motor skills. So we're looking into using the test battery that we've developed for elderly populations or brain injured or Parkinson's patients who need to be tested. You know, it could be used as a diagnostic tool. We also think it could be used as a rehabilitation tool.
Really cool.
It's really cool. We have a couple of universities that are very interested in working with us to kind of move the product in that direction.
So have you done other studies like this?
We've done a number of ground studies looking at fine motor skills, but this is really the first flight study that we've done.
Pretty exciting that you can do it for a year, right?
It is so exciting. You know, we come from human factors and we don't get to do a lot of flight studies, and so we are thrilled to be part of the one-year mission. This is a really great opportunity to complete a data set that is a little bit lacking. So there's been some data in the past on fine motor skills, not interacting with the kind of devices that we're using, but also with a lot of lapses in the data, you know, over the mission. And so this is a great opportunity for us to get data pre-flight, throughout a whole one-year mission, and post-flight, and I think it'll tell a really neat story.
I mentioned earlier that Jeff Williams spent some time this morning on the NanoRacks experiment. Several of those arrived on board Dragon last month, and NanoRacks is a multi-purpose research facility that provides power and data transfer capability to the NanoRacks Cube Labs module. Each NanoRacks platform is about 17 by 9 by 20 inches and weighs just about 12 pounds. They're designed for use within the pressurized space station environment and provide room for up to 16 modules to plug into a standard USB connection. The standardized interface reduces integration costs and schedule for the research. Some of the NanoRacks experiments that Williams is working on today look at things like the shape and growth of small mushrooms in space, the effect of microgravity on bacterial biofilm formation on soft contact lenses, the effect of microgravity on E. coli growth, and the effect of microgravity on how detergent plus polymer beads works on cleaning cotton cloth in microgravity. To work on the experiments, Williams simply has closures that allow 2 parts of the experiment to mix. He opens those and gently shakes them for a prescribed number of seconds, anything from 15 to 120, and allows them to mix. And then they are allowed to scientists on the ground are able to collect that data. to continue their experiment. Takuya Onishi is working now to wrap up an experiment that arrived on the SpaceX Dragon and is now preparing to return to Earth on board it as well, the mouse epigenetics experiment. Onishi's checking up on that experiment today and actually getting it ready for return to home as he moves it into a transfer container for the mice that are part of that experiment. Mouse epigenetics uses mice as a model organisms for humans to study how living in space for long periods of time affects our genetic activity, from changes in gene expression in individual organisms to changes in DNA that can be inherited later. To make that possible, 12 male mice have been living on the space station for about 30 days while the Dragon is here and now will be returning to Earth. And the scientists who are part of the experiment, the thought is that under microgravity conditions, unusual gene expression patterns in normal body cells can be induced by the stresses that come from living without gravity. And other stresses, such as cosmic radiation, may cause unexpected genomic or epigenomic changes in genes in reproductive cells. Scientists will look for changes in the DNA of the mice organs and then look at their offspring to see if their DNA has changed. One of the best ways to keep up with what's going on board the space station is to find out directly from the astronauts who are living there. Many of them have social media accounts and send down updates regularly, and we have a few of those here to share with you today. This one's actually from Kate Rubens. She does not maintain her own account, but she is sending down updates to the NASA astronauts Twitter account. That can be found at NASA_astronauts. And here she sent down a photo that she took during Friday's spacewalk, a selfie looking back at herself inside her spacesuit with the visor down. So you're not really able to see her face, but that is her behind the visor. And this one comes from Jeff Williams, who does have a Twitter account that he updates pretty regularly. That can be found at Astro_Jeff. This one particularly looking at Glacier Bay National Park. The 100th anniversary of the National Park system is coming up actually tomorrow, and Williams has been taking a number of photos of the national parks from space to share. This is a good example. He also sent down this one of Black Hills, South Dakota, and Wyoming, another national park, part of the national park system. And finally, he also turned the camera up to give us a look at what it looks like to see the full moon from the International Space Station. Again, you can find Jeff Williams updates on Twitter at Astro_Jeff, or you can also look for him on Facebook. He's listed as NASA astronaut Jeff Williams. We talk a lot on Space Station Live about the various benefits that we here on Earth receive from the International Space Station. And coming up next, we're going to take a look at some specific ones in Benefits for Humanity, Space is Our Business.
The International Space Station is the most unique laboratory that exists. There are things that you can learn, things that you can do in space that you just can't do on the Earth.
The space station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
What we have is the capability to affect people's quality of life.
It's not just drug companies that can benefit from experiments or research in space, but it's a host of industries across the board.
But it wasn't always easy to get there.
Historically, access to space was limited to companies and corporations, which were selected by the government, and what we lost was the true creativity of so many innovative smaller companies that really didn't understand how to get to space.
When we were doing the reauthorization of NASA, we wanted to expand the opportunities to different areas of experimentation and also different entities.
Recognizing the untapped potential for commercial access to space, in 2005, Congress declared the U.S. portion of the International Space Station a national laboratory.
Essentially, it opened up opportunities for research that could be done on the space station that would benefit us here on Earth.
Everyday companies and everyday researchers and everyday people can think about using the space station. That's a fundamental change that was never allowed before.
Today, we offer opportunities to the researcher that never existed before.
Whether it be seed funding to help support the actual project,
To access to experts to create hardware.
that rocket ride up, the on-station time with the astronaut as your lab technician, what we're doing is really making it as easy as possible for people here on Earth to do space-based research without becoming space experts.
Our part of the mission is to help guide these non-traditional, innovative users from their traditional labs here on the ground to a very unusual and important asset in space. The ISS National Lab has space versions of hardware that you can often find in laboratories here on the ground.
Everything from even animal habitats,
Plant growth chambers,
Freezers,
3D printers,
Earth observation windows,
incubators,
furnaces,
to centrifuges.
microscopes.
the list goes on and on. So we're working with companies that you would never imagine, and they would never have imagined using the International Space Station, and they're seeing great results from that.
And the International Space Station offers researchers like me an opportunity to find the key variables.
It's helping us to pinpoint therapeutic molecules.
The space station really provides us a unique opportunity, a unique environment to do some basic and fundamental research that allows us to develop products better.
The ISS allows us to do a series of experiments in weightlessness that will have profound impacts for life on Earth.
Having a U.S. national lab in space has allowed for the formation of a wide range of companies. It's creating a new economy, a sustainable marketplace that has services, commercial products, competition. There's no limit to what we can be doing in a few years.
As August winds down, we want to make sure that everyone gets the word that in September, NASA will bring its online audience inside the world of human spaceflight as never before, from its Johnson Space Center in Houston, home to NASA's Astronaut Corps and the storied Mission Control, and several human spaceflight programs. New and unique stories from the International Space Station, Orion spacecraft program, and other human spaceflight projects will take viewers behind the scenes of the groundbreaking science taking place off the Earth for the Earth, and the technology NASA is developing to prepare for its journey to Mars. This programming will be available to a worldwide audience on various NASA social media accounts, including YouTube. Space Station Live will be phased out in August and discontinued September 1st. However, NASA TV will continue to air live coverage of dynamic space station operations, including launches, dockings, landings, spacewalks, and briefings. NASA TV will also continue to air weekly highlights of life on board station and the short format Space to Ground program, also available on YouTube and via podcast. These changes will not affect live video streams from the International Space Station. Viewers can continue to see those live video streams as long as the ISS has signal on Ustream and via the High Definition Earth Viewing, or HDEV, payload. Daily updates on space station research and operations will continue to be posted to the International Space Station blog, as will more detailed daily rundowns of crew activities on the In-Orbit Status Report blog. Digital audiences also have the option of receiving weekly video highlights by subscribing to Johnson's newsletter, news release email list, or check out the hundreds of hours of raw video from Space Station that is available for download from Johnson's video collection archive, with additional video added daily. For more information and links to all of those resources, you can visit nasa.gov/station. We're coming up now on the end of today's Space Station Live, but of course you'll want to stay tuned as usual at 11 a.m. Central for the NASA TV video file to get a look at other activities going on at NASA centers across the country. And then for sure, stay tuned at 1 p.m. Central Time to get a look at the spacewalk that Jeff Williams and Kate Rubins will be performing on September 1st. That spacewalk preview briefing, again, will be taking place here on NASA TV at 1 p.m. Central Time. This is Mission Control Houston.
Attention, all cable and satellite television providers and viewers. NASA television channels NTV1 and 2 are now transmitting from Galaxy 13 Transponder 11. Please make the switch to this new satellite to continue receiving all your favorite NTV programs. For more information, visit www.nasa.gov/NTV and click on Finding NASA TV on Satellite Galaxy 13.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Good morning and welcome to Mission Control Houston and Space Station Live. It's a busy and also historic day on board the International Space Station today. The Space Station crew is made up of Commander Jeff Williams and Flight Engineer Kate Rubins, both of NASA, Japan Aerospace Exploration Agency Flight Engineer Takuya Onishi, and Russian flight engineers Alexei Ovchinin, Oleg Skropochka, and Anatoly Ivanishin. Williams, Ovchinin, and Skropochka have been at the station since March 18th and are quickly running out of time in their mission. They're scheduled to head home on September 6th. However, as of today, Williams has already been in space long enough to break the previous record for most time spent in space by a U.S. astronaut. That previous record was 520 days set by Scott Kelly during his year-long mission, and Kelly actually dropped into Mission Control Houston today to congratulate Williams on the achievement.
Hey, Jeff, it's Scott Kelly.
Hello, Scott. How you doing? I recognized your voice before you said Scott Kelly.
Hey, I wanted to congratulate you on passing me up here and total number of days in space. It's great to see another record broken, and especially by a sardine. But I do have one question for you. And my question is, you got another 190 days in you?
Another 190 days. I mean, that question is not for me. That's for my wife.
Hey, great job on the EVAs. I was watching you from my house, and great job to Kate and Talk for getting you guys in and out. That was great. That was supposed to be the EVA, or the first one that Jill and I was going to do. I don't know if you recall that, but hey, great job, and great to talk to you guys today. Congratulations again.
I do remember that, and we never expected to do it. Kate and Talk did an awesome job. It was a good day. Of course, the hardware treated us right, and the team on the ground set us up for success. So we came off that day very happy. Great to talk to you. And I think I told you congratulations before on your success, although we didn't have many opportunities to talk, but successfully doing that one-year flight. Thank you again for doing it so I didn't have to. I often say, those of my family that didn't want me to come, I said, you know, if I did the 1 year, I'd be home 6 months earlier, and that never flew it with anybody. They preferred delaying 6 months as opposed to going 1 year earlier. But well done on you, and I hope your transition to your post-NASA is going well.
Yeah, so far so good, and yeah, obviously I haven't seen you since I launched there in Baikonur, so look forward to seeing you when you get back. Hopefully I'll be out there in early next month in the middle of the night when you guys get home.
Sounds good, Scott. Look forward to seeing you there. I still remember you being there when I returned from Expedition 13, and I appreciated that.
All right, take it easy. Sorry to bother your lunch.
Thanks for bothering us. We enjoyed talking to you. Take care.
All right, bye-bye. Bye, Kate.
That again was Scott Kelly earlier this morning congratulating Jeff Williams on breaking the record that Kelly set for longest stay in space by a U.S. astronaut today. Williams will continue racking up the new record and leave it set at 534 cumulative days in space when he returns home on September 6th. That time was accrued by Williams over 3 long-duration space station stays, Expedition 13 in 2006, Expeditions 21 and 22 in 2009 through 2010, and this current expedition, as well as 1 space shuttle mission. He was on STS-101 in 2000 as well. The 534-day mark will put him in 14th place on the all-time endurance list. Scott Kelly, meanwhile, will hold on to the record for consecutive days in space by a U.S. astronaut. He spent 340 days in space as part of his 1-year mission, which wrapped up in March. You also heard Kelly refer to himself and Williams as sardines. They were both part of the 1996 astronaut class, and that was that class's nickname. For the rest of the crew members currently on board, Rubens, Onishi, and Ignition still have a couple of months to go in their current stay. They launched the station on July 6th and are scheduled to stay in space until the end of October. Once Williams, Ovchinin, and Skropochka have departed, they'll be joined by NASA astronaut Shane Kimbrough and Russian cosmonauts Andrei Borisenko and Sergei Ryzhkov, who will be launching from Kazakhstan on September 23rd. But there is a lot of work to get through before then, including the departure of the SpaceX Dragon cargo craft this Friday at 5:10 a.m. Central Time, and another spacewalk next Thursday on September 1st, during which Rubens and Williams will be retracting the trailing thermal controller radiator and installing HD cameras on the space station. You're going to get a chance to learn more about that at 1 p.m. today here on NASA TV in our Spacewalk Preview briefing. Again, that'll be coming up on NASA TV at 1 p.m. Central Time today. Preparations for both of those activities are on the crew's agenda for today. Williams and Rubens are reviewing procedures for the upcoming spacewalk and have spent a good amount of time in the Quest airlock getting their spacesuits ready for the various, and also recharging the various batteries that they'll need. You can see a view here of Rubens and Williams inside the Quest earlier this morning with their spacesuits behind them. Again, that spacewalk is scheduled for a week from Thursday on September 1st. Rubens and Onishi, meanwhile, will be moving into the robotic workstation on the cupola before the end of the day to brush up on their robotics training in preparation for Friday's robotic release of the SpaceX Dragon. In addition, there was a good deal of transfer work going on in preparation for the Dragon's hatch closure tomorrow. Williams was replacing a lyo filter on board while Rubens moved over one of the polar freezers that will make sure science experiments make it to the ground in good condition. And Onishi moved the habitat being used for the mouse epigenetics experiment back over to the Dragon for return to scientists on the ground. Williams also found some time for scientific work. He mixed up a number of NanoRacks experiments that look at a range of questions, including microgravity's effects on E. coli bacteria and microgravity's effects on the ability of detergent and polymer beads to clean a cotton cloth. And finally, the station also received a reboost in altitude early this morning using the Progress 63's engines, which fired for a total of 12 minutes and 9 seconds. The station's apogee, or the high point of its orbit, was increased by 1/10 of a mile, and its perigee, the low point of the orbit, moved 2.9 miles higher. The station's now circling the Earth in a 253.5 by 248 mile orbit, and just at the moment it's about 255 miles above the Indian Ocean, heading southeast around the southern coast of Australia. Flight engineer Kate Rubin spent some time this morning working to replace a rotor in the European Modular Cultivation System rack. You can see her and Jeff Williams in this video recorded from earlier today working on that project. The EMCS, as that's called, is dedicated to studying plant biology in a reduced gravity environment. It can support the cultivation, stimulation, and crew-assisted operation of biological experiments under controlled temperatures, water supplies, illumination levels, gravity levels, and atmospheric composition. It's been used to perform multi-generation experiments that cultivate plants for seeds and then grow the seeds as well, looking at the effects of gravity and light on the early development of growth in plants. It can also house experiments with insects, amphibians, and invertebrates in the future, as well as cell and tissue cultures. The facility uses an incubator with 2 slowly rotating rotors, which is what today's maintenance was focusing on. Each rotor can accommodate up to 4 experiment containers, each of which house dedicated hardware for particular experiments. collect that data to continue their experiment. Takuya Onishi is working now to wrap up an experiment that arrived